Look closely at nothing. Hold your hand in front of you and look at the space between your fingers. It feels empty, calm, still. It is none of those things. In the volume you could hold in your palm, reality is in violent, ceaseless motion. Particles are flickering into existence and vanishing again, billions upon billions of times, in every fraction of a second, faster than any clock could ever record. They are born from nothing. They die into nothing. And they leave no trace your eyes were ever built to see. This is the vacuum. Not a stage where the universe performs, but the deepest layer of the universe itself. Strip away every star, every planet, every last atom of matter. Cool it to the lowest energy nature will allow. What remains is not emptiness. What remains still trembles. For a century, physics has been telling us something our intuition refuses to accept. There are no tiny solid balls at the heart of matter. An electron is not a speck. It is a ripple, a disturbance in an invisible field that fills all of space. The light reaching your eyes right now is a wave in another. Every particle you are made of is a vibration in an ocean you cannot perceive, an ocean that was here long before you and stretches further than any telescope will ever reach. And these fields are not silent. They cannot be. The laws of quantum mechanics forbid perfect stillness. So even in the absolute dark between galaxies, in the void we once called nothing, energy seethes. Particles and their antiparticles surface in pairs and annihilate. The emptiness pushes back on metal plates. It nudges the orbits of electrons. It glows faintly at the edge of a black hole. We have measured it. It is real. And here is the part that should keep you awake tonight. 14 billion years ago, the entire cosmos was small enough to be governed by this trembling. The faint, random flickers of the quantum vacuum were stretched by the violent expansion of the early universe across the heavens. Those imperfections became the seeds of everything. Every galaxy, every star, every world. You. We owe our existence to the restlessness of nothing. And tonight, we descend into it. Step outside on a clear, moonless night and look up. Between the scattered points of starlight, the sky seems to be made of pure absence, a vast black canvas onto which a few bright objects have been painted. Your eyes report a simple truth: the universe is mostly empty. Or so it seems. That single assumption, that the dark between things is nothing, is one of the oldest mistakes in human history. And the story of how we uncovered it is one of the strangest in all of science. To understand the illusion, we first have to understand why we fell for it. Human beings evolved to track what could feed us, threaten us, or be thrown at us. We are tuned to surfaces, to the edges of solid things, to objects we can grasp. Whatever cannot be touched, our senses bundle into a single useless category: empty. It was a brilliant survival strategy on the plains of Africa. It is a catastrophic way to understand the cosmos. Because the things our ancestors could safely ignore turn out to be almost everything that exists. For most of recorded history, the greatest minds shared the same blind spot. In ancient Greece, Aristotle declared that a true void was not merely difficult to create, but logically impossible. Nature abhors a vacuum, he insisted, and for nearly 2,000 years, Europe believed him. If you tried to make a pocket of perfect nothingness, the world would rush in to fill it. Emptiness, to the ancient mind, was a wound in reality that reality would instantly heal. The first cracks in that belief appeared not in a temple of philosophy, but in a workshop with a tube of mercury. In the 17th century, an Italian physicist named Evangelista Torricelli sealed liquid metal inside a glass tube, turned it upside down into a dish, and watched the mercury fall. But not all the way. It stopped, leaving a gap at the top that nothing had entered. No air, no water, no matter of any kind. He had made a void on a tabletop, and the heavens had not collapsed to fill it. Soon after, in a German town, the engineer Otto von Guericke pumped the air out of two metal hemispheres pressed together and harnessed teams of horses to either side. The horses strained. The sphere held. The emptiness inside was gripping the metal shut with the full weight of the atmosphere outside. For the first time, humanity had proven you could carve a hollow out of the world. The vacuum was real. Aristotle was beaten, and physics settled into a comfortable new picture. Space was a stage after all, but an empty stage was perfectly allowed. Remove every particle from a box, and what remained was true, absolute, featureless nothing. That picture was about to be destroyed twice over. The first blow came from inside matter itself. When physicists finally peered into the atom, the supposed solid building block of all things, they found something that should have been impossible. The atom is almost entirely empty space. Picture the nucleus, the dense knot of protons and neutrons at an atom's heart, blown up to the size of a single pea and placed at the center of a great cathedral. On that scale, the electrons would be flecks of dust drifting near the distant walls. Everything in between, the entire cavernous interior, is void. No substance, no surface, just fields holding the whole arrangement together. Now, consider what this means for you. The chair beneath you feels solid. Your own hand feels solid. But matter, at its core, is more than 99.9999% empty. The solidity you feel your entire life is woven from forces, not stuff. When you press your palm against a table, not a single particle in your hand ever truly touches the wood. You are sensing repulsion across a gap. Emptiness pushing back against emptiness. The universe is built almost entirely out of the very nothing we learned to ignore. But here is where the cosmos offers a breathtaking demonstration of what that emptiness is hiding. Imagine you could reach into a star and squeeze. Press the atoms together until all that internal void was crushed out, until nothing was left but matter packed wall to wall. You don't have to imagine. The universe does it. When a massive star dies, its core collapses under its own gravity with a violence beyond comprehension. Gravity crushes away most of the empty space between the nuclei and electrons, forcing matter into an extraordinarily dense state. What remains is a neutron star, a city-sized sphere holding more mass than our sun, so tightly packed that a single teaspoon of its material would weigh roughly 1 billion tons. A sugar cube fragment outweighs a mountain range. Let that sink in. The terrifying compactness of a neutron star is not telling you how heavy matter is. It is telling you how astonishingly empty ordinary matter was to begin with. At its most extreme, a neutron star can wrap itself in the most powerful magnetic field nature ever produces, becoming a magnetar, violent enough to crack its own crust. And if the dying core is heavier still, gravity doesn't stop at a neutron star at all. It wins completely, and the matter vanishes behind a black hole, the final endpoint of collapse, where space itself folds shut. One idea runs through all of them. Remove the emptiness, and density explodes beyond imagination. So matter is mostly nothing. That was the first blow. The second came from the largest scales imaginable. Look back up at the dark between the stars. If matter near you is mostly empty, surely that, the abyss between galaxies, is the genuine article. Pure, perfect vacuum. It is the emptiest place we know. And it is still not empty. The space between stars in our own galaxy is laced with thin clouds of gas and dust, the nurseries from which new suns are born. Travel beyond the galaxy, out into the great cosmic voids, immense dark bubbles hundreds of millions of light years across, and the gas thins to something almost beyond belief. On average, only a handful of atoms in a volume the size of your own body. By any human standard, this is the most profound emptiness conceivable. The finest vacuum chambers ever built on Earth are crowded, bustling cities of particles by comparison. And yet, almost empty is not empty. Those few lonely atoms are still there. Faint threads of matter still stretch across even the darkest gulfs, connecting galaxy to galaxy in a cosmic web spanning the entire observable universe. The light of distant quasars still streams through. Magnetic fields still thread the dark. There is no corner of the cosmos, however remote, that contains nothing. This leads to a haunting realization, and it is the doorway to everything that follows. No matter where you go, no matter how thoroughly you clean it out, you can never quite reach perfect emptiness. You can pump out the air, you can remove the dust, you can travel to the loneliest void between galaxies and sweep away the final few atoms. You can imagine the ultimate laboratory, a sealed box, cooled toward the coldest temperature the laws of physics allow, with every last particle of matter extracted. And when you have done all of that, when you have removed everything that can possibly be removed, you will not have reached nothing. You will have reached a floor, a lowest possible state, a bottom to reality below which you cannot dig. And that floor is not still. It is not silent. It is not empty. For 2,000 years, we argued about whether a vacuum could exist. We finally learned to build one, only to discover that the true and total nothing we had been chasing all along is forbidden by the deepest laws of nature. Strip the universe to its absolute minimum, and something always remains. The question is no longer whether empty space is empty. The question is what that something is. Beneath every atom, beneath every star, beneath empty space itself, lies something we cannot see. Not particles, not matter, but fields. And once you understand them, the universe will never look empty again. Right now, light is landing on you that began its journey before you were born. Some of it left stars that no longer exist, suns that burned out millennia ago, their final glow still crossing the dark to reach your eyes tonight. We call these messengers photons, and for centuries we pictured them as tiny grains of light, little bullets flung across the cosmos. We pictured electrons the same way, and protons and every other piece of matter as minuscule solid spheres, the smallest marbles in nature's bag. That picture is wrong. Not slightly wrong, wrong at its foundation. There are no marbles. To find what is actually there, we have to perform the strangest inversion in the history of physics. We have to stop asking what things are made of and start asking what they are made from. And the answer is something that has no edges, no surface, no location. Something that is everywhere at once. A field. Most of us first met the word in a classroom, holding a magnet over iron filings and watching them leap into curved lines. That invisible influence reaching out from the magnet, present in the space around it, real enough to move metal, yet impossible to see, that is a field. A quantity that has a value at every single point in space. Hold that idea, because we are about to push it far beyond magnets, far beyond anything your intuition is ready for. In the deepest description we have of reality, quantum field theory, the most precisely tested framework in all of science, fields are not features of the universe. They are the universe. They are the bottom layer, the bedrock. And they do not sit in space like objects in a room. They fill it completely, every cubic millimeter of it, stretching unbroken across the entire cosmos. There is no place you can point to where they are not. So what then is a particle? A particle is what happens when you disturb a field. Pluck a guitar string and it hums with a note. Drop a stone in still water and a ripple races outward. The note is not a separate object from the string. It is the string, vibrating. In exactly this way, every particle in existence is a vibration, an excitation, a ripple, rising up out of a field that was always there. Add a precise packet of energy to a field, and the field quivers in response. And that quiver, that humming knot of energy, is what we have been calling a particle for 200 years. The field is the instrument. The particle is the note it plays. This is not a metaphor stretched for the sake of a documentary. It is the literal mathematics of how nature works. And it dissolves a mystery that haunted physics for generations. Consider this. Every electron in the universe is identical. Not similar, identical. To a precision beyond anything humans can manufacture. The electrons inside your body, the electrons inside the sun, the electrons inside a galaxy on the far side of the observable universe, all share exactly the same mass, exactly the same charge, with no variation whatsoever. Why? How could trillions upon trillions of separate objects, scattered across billions of light years, be perfect copies of one another? Because they are not separate objects. There is only one electron field, spread across all of space. And every electron, everywhere, is a ripple in that single field. They are identical for the same reason every wave on the same ocean is unmistakably a wave of that ocean. There was never a factory stamping out matching marbles. There is one vast, invisible medium. And what we call particles are simply the places where it happens to be vibrating. Now multiply that revelation across all of nature. The light from those dying stars, that is the electromagnetic field, and the photons crossing the void to reach you are nothing but ripples traveling across it. Radio waves, the warmth of sunlight, X-rays screaming out of a disk of matter spiraling into a black hole. Every one of them is the same field, the same ocean, vibrating at a different pitch. When a magnetar unleashes a flare bright enough to disturb the atmosphere of a planet thousands of light years away, what reaches across that gulf is not a swarm of objects. It is a disturbance in a field that was already touching both the star and the planet all along. Go deeper into the heart of any star. There, crushed together by gravity and heat, sit protons and neutrons, and they are not fundamental either. Each one is built from quarks, and quarks are ripples in quark fields, bound together by yet another field whose excitations we call gluons. These bind so ferociously that a quark can never be pulled free and left alone. Try to separate one, and the energy you pour in simply conjures new quarks from the field itself. Everything solid you have ever known, every rock, every world, every dense remnant of a collapsed star, is, at its root, the trembling of these fields locked in a grip that nothing in the cosmos can break. Then there are the ghosts. When a massive star dies and its core collapses, it releases an almost unimaginable flood of neutrinos, ripples in the neutrino fields, the faintest tremor nature knows how to make. They barely interact with anything at all. From a single dying star, so many pour out that they pass straight through entire planets as though the matter were not there. Trillions are streaming through your body in the time it takes to read this sentence, and you will never feel a single one. They are the most antisocial whispers in the universe, proof that the fields are speaking constantly, in voices we are almost entirely deaf to. And woven invisibly through all of it lies the strangest field of all, the Higgs field. Unlike the others, the Higgs does not switch off in empty space. It holds a value everywhere, a constant, unseen presence soaked into the fabric of the cosmos. And as particles move through it, this field clings to them, resists them, slows them. And that resistance is what we experience as mass. An electron has mass because it drags against the Higgs. A particle that ignores the Higgs entirely, like the photon, has no mass at all, and so it flies forever at the speed of light, never slowing, never tiring. The weight of nearly everything you have ever lifted traces back to an interaction with a field you cannot see, switched on throughout all of space, since the universe was a fraction of a second old. We did not confirm it existed until 2012, when, deep beneath the French-Swiss border, physicists slammed particles together hard enough to make the Higgs field ring, and detected its single faint note. Now step back and take in the whole picture. At every point in space, inside this room, inside the sun, inside the most desolate void between galaxies, all of these fields exist at once. The electron field, the electromagnetic field, the quark and gluon fields, the neutrino fields, the Higgs. They overlap completely, occupying the same volume without crowding one another, transparent and intermingled, layered one atop the next like countless invisible oceans poured into the very same space. You are not a collection of tiny, solid things drifting through emptiness. You are a temporary, beautifully orchestrated pattern of ripples. Knots of vibration rising out of a dozen overlapping fields, holding their shape for a while, exchanging energy, and one day relaxing back into the medium they came from. Every star is the same, every galaxy. The cosmos is not a stage with objects placed upon it. The cosmos is the fields. And here is the part that finally shatters the old idea of empty space for good. When physicists say a region contains no particles, they do not mean the fields are gone. The fields can never be gone. They stretch unbroken through all of existence, and you cannot remove them any more than you could remove the ocean and leave the waves behind. What empty really means is that the fields are simply quiet, lying at rest, holding their lowest value, with no ripple rising up to be called a particle. So that perfect vacuum we chased for 2,000 years, that flaw of reality we finally found at the bottom of everything, is not an absence at all. It is an ocean at rest. Which raises the question that should be impossible to ignore. If these fields are truly everywhere, beneath your skin, between the stars, filling the loneliest gulfs of the universe, then why does space still look so empty? Why has no one ever felt this ocean? Why, when you stretch out your hand into the dark, do you touch nothing at all? The answer is the most unsettling discovery in this entire story. Because the fields are not quiet. They were never quiet. And the stillness of empty space is the greatest lie your senses have ever told you. Right now, light is landing on you that began its journey before you were born. Some of it left stars that no longer exist, suns that burned out millennia ago, their final glow still crossing the dark to reach your eyes tonight. We call these messengers photons, and for centuries we pictured them as tiny grains of light, little bullets flung across the cosmos. We pictured electrons the same way, and protons and every other piece of matter as minuscule solid spheres, the smallest marbles in nature's bag. That picture is wrong. Not slightly wrong, wrong at its foundation. There are no marbles. To find what is actually there, we have to perform the strangest inversion in the history of physics. We have to stop asking what things are made of and start asking what they are made from. And the answer is something that has no edges, no surface, no location. Something that is everywhere at once. A field. Most of us first met the word in a classroom, holding a magnet over iron filings and watching them leap into curved lines. That invisible influence reaching out from the magnet, present in the space around it, real enough to move metal, yet impossible to see, that is a field. A quantity that has a value at every single point in space. Hold that idea, because we are about to push it far beyond magnets, far beyond anything your intuition is ready for. In the deepest description we have of reality, quantum field theory, the most precisely tested framework in all of science, fields are not features of the universe. They are the universe. They are the bottom layer, the bedrock, and they do not sit in space like objects in a room. They fill it completely, every cubic millimeter of it, stretching unbroken across the entire cosmos. There is no place you can point to where they are not. So what, then, is a particle? A particle is what happens when you disturb a field. Pluck a guitar string and it hums with a note. Drop a stone in still water and a ripple races outward. The note is not a separate object from the string. It is the string vibrating. In exactly this way, every particle in existence is a vibration, an excitation, a ripple, rising up out of a field that was always there. Add a precise packet of energy to a field, and the field quivers in response. And that quiver, that humming knot of energy, is what we have been calling a particle for 200 years. The field is the instrument. The particle is the note it plays. This is not a metaphor stretched for the sake of a documentary. It is the literal mathematics of how nature works. And it dissolves a mystery that haunted physics for generations. Consider this. Every electron in the universe is identical. Not similar, identical, to a precision beyond anything humans can manufacture. The electrons inside your body, the electrons inside the sun, the electrons inside a galaxy on the far side of the observable universe all share exactly the same mass, exactly the same charge, with no variation whatsoever. Why? How could trillions upon trillions of separate objects scattered across billions of light years be perfect copies of one another? Because they are not separate objects. There is only one electron field spread across all of space. And every electron, everywhere, is a ripple in that single field. They are identical for the same reason every wave on the same ocean is unmistakably a wave of that ocean. There was never a factory stamping out matching marbles. There is one vast, invisible medium. And what we call particles are simply the places where it happens to be vibrating. Now multiply that revelation across all of nature. The light from those dying stars? That is the electromagnetic field, and the photons crossing the void to reach you are nothing but ripples traveling across it. Radio waves, the warmth of sunlight, X-rays screaming out of a disk of matter spiraling into a black hole. Every one of them is the same field, the same ocean, vibrating at a different pitch. When a magnetar unleashes a flare bright enough to disturb the atmosphere of a planet thousands of light years away, what reaches across that gulf is not a swarm of objects. It is a disturbance in a field that was already touching both the star and the planet all along. Go deeper into the heart of any star. There, crushed together by gravity and heat, sit protons and neutrons, and they are not fundamental either. Each one is built from quarks, and quarks are ripples in quark fields, bound together by yet another field whose excitations we call gluons. These bind so ferociously that a quark can never be pulled free and left alone. Try to separate one, and the energy you pour in simply conjures new quarks from the field itself. Everything solid you have ever known, every rock, every world, every dense remnant of a collapsed star is, at its root, the trembling of these fields locked in a grip that nothing in the cosmos can break. Then there are the ghosts. When a massive star dies and its core collapses, it releases an almost unimaginable flood of neutrinos, ripples in the neutrino fields, the faintest tremor nature knows how to make. They barely interact with anything at all. From a single dying star, so many pour out that they pass straight through entire planets as though the matter were not there. Trillions are streaming through your body in the time it takes to read this sentence, and you will never feel a single one. They are the most antisocial whispers in the universe. Proof that the fields are speaking constantly, in voices we are almost entirely deaf to. And woven invisibly through all of it lies the strangest field of all, the Higgs field. Unlike the others, the Higgs does not switch off in empty space. It holds a value everywhere, a constant, unseen presence soaked into the fabric of the cosmos. And as particles move through it, this field clings to them, resists them, slows them. And that resistance is what we experience as mass. An electron has mass because it drags against the Higgs. A particle that ignores the Higgs entirely, like the photon, has no mass at all, and so it flies forever at the speed of light, never slowing, never tiring. The weight of nearly everything you have ever lifted traces back to an interaction with a field you cannot see, switched on throughout all of space since the universe was a fraction of a second old. We did not confirm it existed until 2012, when, deep beneath the French-Swiss border, physicists slammed particles together hard enough to make the Higgs field ring, and detected its single faint note. Now step back and take in the whole picture. At every point in space, inside this room, inside the sun, inside the most desolate void between galaxies, all of these fields exist at once. The electron field, the electromagnetic field, the quark and gluon fields, the neutrino fields, the Higgs. They overlap completely, occupying the same volume without crowding one another. Transparent and intermingled, layered one atop the next, like countless invisible oceans poured into the very same space. You are not a collection of tiny solid things drifting through emptiness. You are a temporary, beautifully orchestrated pattern of ripples, knots of vibration rising out of a dozen overlapping fields, holding their shape for a while, exchanging energy, and one day relaxing back into the medium they came from. Every star is the same. Every galaxy. The cosmos is not a stage with objects placed upon it. The cosmos is the fields. And here is the part that finally shatters the old idea of empty space for good. When physicists say a region contains no particles, they do not mean the fields are gone. The fields can never be gone. They stretch unbroken through all of existence, and you cannot remove them any more than you could remove the ocean and leave the waves behind. What empty really means is that the fields are simply quiet, lying at rest, holding their lowest value, with no ripple rising up to be called a particle. So that perfect vacuum we chased for 2,000 years, that flaw of reality we finally found at the bottom of everything, is not an absence at all. It is an ocean at rest, which raises the question that should be impossible to ignore. If these fields are truly everywhere, beneath your skin, between the stars, filling the loneliest gulfs of the universe, then why does space still look so empty? Why has no one ever felt this ocean? Why, when you stretch out your hand into the dark, do you touch nothing at all? The answer is the most unsettling discovery in this entire story. Because the fields are not quiet. They were never quiet. And the stillness of empty space is the greatest lie your senses have ever told you. We left the ocean at rest. Now we have to confront a truth that the founders of quantum physics resisted for years. because it sounded less like science than like madness. The fields can never hold perfectly still. Not because we lack the tools to calm them. Not because some leftover heat keeps stirring them. Because the laws of nature forbid perfect stillness. Flatly, permanently, everywhere. And the reason traces back to a single rule, the most famous and most misunderstood idea in all of quantum mechanics. It is called the uncertainty principle, and it is far stranger than its reputation. Most people first hear it as a statement about measurement, that you cannot know exactly where something is and exactly how fast it is moving at the same time. True, but that framing makes it sound like a limit on us, a problem with our instruments, as though nature has a definite answer and we are simply too clumsy to read it. That is not what is happening. The uncertainty is not in our knowledge, it is in reality itself. A field at a point in space cannot simultaneously have a perfectly fixed value and be perfectly unchanging. Nature does not permit both at once. If a field ever fell completely silent, zero value, zero motion, absolute calm, it would be breaking the deepest rule of how things are allowed to exist. So, it never does. Pin a field down toward stillness, and it must wobble. Force the wobble to settle, and its value blurs. There is no setting on the dial of the universe marked off. Even at the coldest temperature physics allows, even with every particle stripped away, the fields are left with a faint, irremovable jitter, a tremor they can never shed. We call it zero-point motion, the trembling that remains when there is nothing left to remove. This is the engine room of everything that follows. The vacuum, that ocean at rest we reached at the bottom of reality, is not lying flat and silent. It is shivering, constantly, forever. In every cubic inch of the cosmos, the fields are humming at their lowest possible energy. And that lowest possible energy is not zero. And here is where the shivering produces something astonishing. Because the fields jitter, their energy at any tiny patch of space is never quite settled. It flickers up and down around its baseline. And energy, as we have known for a century, can become matter. So in that flickering, every so often, the vacuum borrows a fleeting surplus of energy and spends it the only way it can. It conjures particles into existence. They are called virtual particles, and they are the ghosts that live inside empty space. Out of the trembling fields, a particle and its mirror image antiparticle surface together. An electron and an anti-electron, say, flashing into being where an instant before there was nothing. They exist for a span of time so short it nearly defies meaning, a sliver of a second. Then they find each other, collide and annihilate, returning the borrowed energy before the universe can ever notice the debt. The vacuum settles its account in full every time. Picture it across a region of seemingly empty space, a sea constantly frothing. Pairs of particles boiling up from nowhere and vanishing back into nowhere trillions of times over in every direction without pause. A hidden, seething activity underlying what looks to us like perfect calm. The emptiness is not a place where nothing happens. It is the busiest place in the universe. For decades, this sounded like pure mathematics, an accounting trick in the equations with no way to ever see it. After all, how do you detect particles that vanish before they can be caught? How do you prove that nothing is secretly doing something? Nature, it turned out, had left fingerprints. The first came from squeezing the void. Take two flat metal plates and bring them extraordinarily close together, almost touching, in the emptiest vacuum you can build. Out in the open space around them, the trembling fields can vibrate at any pitch they like, the full spectrum of possibilities frothing freely. But in the narrow gap between the plates, only certain vibrations fit. The others are simply too large to exist in so thin a space. So the gap is starved. Fewer fluctuations are allowed inside than outside. And that imbalance has a consequence you can measure. The richer froth on the outside presses inward harder than the thinned-out froth between can push back, and the two plates are shoved together by nothing but the difference in the vacuum's own trembling. A force pushing on solid metal sourced from empty space. It is real. It has been measured in laboratories exactly as predicted. We call it the Casimir effect, and it remains one of the most direct demonstrations that the vacuum is alive. The second fingerprint was even subtler and even more convincing. Inside every atom, electrons orbit the nucleus, and they do not feel only the nucleus's pull. They are also being jostled ceaselessly by the froth of virtual particles boiling around them. That constant buffeting nudges an electron's energy by a whisper, a shift so tiny it took some of the most precise measurements ever performed to catch it. But catch it we did. The electron sits exactly where the seething vacuum says it should, not where a calm and empty space would put it. That minuscule discrepancy, the Lamb shift, is the vacuum reaching into the heart of every atom in your body and leaving its mark. Two utterly different experiments, two completely independent confirmations. The conclusion is no longer in doubt. The quantum vacuum is not a theory, it is a measured fact. But the most spectacular consequence of all is written not in a laboratory. It is written across the sky, at the edge of the darkest objects in existence. Return to a black hole. We met it as the final endpoint of collapse, the place where space folds shut and not even light can escape. For most of the 20th century, we believed that was the whole story, that a black hole only ever swallows, growing forever, giving back nothing. Then the trembling vacuum changed everything. Consider that frothing sea of particle pairs surfacing and annihilating, now playing out right at the edge of a black hole, at the boundary of no return. Normally, a virtual pair appears, finds its partner and vanishes, the debt instantly repaid. But at that knife edge, something can go terribly wrong. One member of the pair slips across the boundary and falls in, lost forever. Its partner, suddenly with nothing left to annihilate against, is stranded on the outside and escapes into space as a real particle, carrying away energy that has nowhere to come from but the black hole itself. Particle by particle, over spans of time longer than the present age of the cosmos, the black hole pays. It loses energy. It loses mass. It very slowly shrinks. The most inescapable objects in the universe are not eternal after all. They evaporate, bleeding away into the dark, one ghost from the vacuum at a time. We call this faint glow Hawking radiation, and it means even a black hole is at the mercy of empty space's restless trembling. Sit with the full weight of what we have uncovered. The vacuum is not nothing. It shivers because it must. That shivering conjures fleeting matter from emptiness, presses on metal plates, shifts the orbits of electrons, and slowly dismantles the most powerful gravitational traps in existence. Everything we once filed under nothing is, in truth, a roiling, energetic, measurable presence. The most active stage in all of physics, hiding in plain sight behind the illusion of calm. And once you accept that empty space is this alive, this charged with restless, creative energy in every corner of the cosmos, a far larger question becomes impossible to avoid. If the trembling of the vacuum can pull particles out of nothing today, if it can reach into atoms and unmake black holes, then what could it have done at the one moment when all of space was squeezed smaller than a single atom, when the entire universe was nothing but trembling vacuum and there was no froth too small to matter? The same restless flickers we have been chasing through empty space may be the reason there is anything to fill it. The reason there are stars at all. The reason there is a you to wonder about any of it. Rewind the universe. Take everything you can see, every star, every galaxy, the whole luminous sprawl of the cosmos, stretching billions of light years in every direction, and run the film backward. The galaxies rush together. The space between them shrinks. The cosmos grows hotter, denser, smaller, collapsing inward across nearly 14 billion years of history, compressed into a single, dwindling point. Keep rewinding, and you arrive at a moment so extreme that everything familiar breaks down. The entire observable universe, all of it squeezed into a region smaller than a single atom. This is the beginning. And the question that has haunted cosmology for a century is brutally simple. How did that become this? How do you get from a featureless, white-hot speck to a universe threaded with galaxies, stars, planets, and the rare, warm worlds where someone can look up and ask the question at all? Something had to break the perfect smoothness of the early cosmos. Something had to plant the first seeds, the original unevenness from which all structure would one day grow. And the answer, astonishingly, is the very thing we have spent this entire journey uncovering. First, a confession about the beginning itself. We do not know what came before. The honest edge of science is exactly here. Trace the cosmos back far enough, and our equations, powerful as they are, stop giving sensible answers. The instant of the beginning is veiled. There are ideas that our universe emerged from a deeper, pre-existing state, that time itself had no before, that what we called the start was a transition rather than a true birth. These are serious hypotheses, pursued by serious minds, but they remain unconfirmed. No one was there. No instrument can yet reach back that far. So we begin the story not at the absolute first instant, but a hair after it, at the earliest moment we can actually describe. And what we find there is a universe almost perfectly smooth, almost perfectly uniform. But trembling, because the fields were there. They are always there, and we have already learned the iron rule they obey. They can never hold perfectly still. Even in that newborn cosmos, The vacuum was doing what the vacuum always does, flickering, fluctuating, humming with its irremovable jitter, raising up faint ripples of slightly more here and slightly less there across the infant universe. In any ordinary moment, those flickers would do what they always do: appear, vanish, and leave no lasting trace, too small to matter, gone before the universe could notice. But this was not an ordinary moment. In the first unimaginably tiny fraction of a second, the universe did something violent and almost beyond belief. It expanded, not gently, not gradually, but explosively, doubling in size again and again and again, faster than the speed of light itself stretches space. In an interval so brief it has no meaningful comparison in human experience, a patch smaller than a proton was inflated to cosmic proportions. We call this event cosmic inflation, and it is the single most consequential thing that has ever happened because of what it did to those tiny quantum flickers. The microscopic ripples in the fields, the faint, fleeting unevenness of the trembling vacuum, were caught in that runaway expansion and stretched. Before they could flash out of existence as they always had, the explosive growth of space seized them and pulled them outward, blowing them up from subatomic whispers to scales spanning the entire visible cosmos. What had been a momentary quantum tremor was frozen into the fabric of reality, enlarged beyond any chance of vanishing, made permanent by the sheer speed of the universe's expansion. The vacuum's smallest, most fleeting accidents were promoted in an instant to the foundation of everything. When inflation finally ended and the universe settled into its more sedate expansion, it was no longer perfectly smooth. It carried the faint fossil of those quantum tremors, regions a whisper denser than their surroundings, and regions a whisper thinner, frozen into the fabric of reality after existing for less than an eye blink. These were the seethes, the first unevenness the cosmos had ever known. And every structure that would ever exist was waiting, encoded inside them. Now gravity took over, and it is patient. In the regions that were a little denser, there was a little more matter, and so a little more gravitational pull. Those regions drew in material from their thinner surroundings, growing denser still, which deepened their pull, which drew in more. Over millions of years, the faint overdensities snowballed. Matter flowed downhill into the seeds the vacuum had planted, draining out of the emptier zones and pooling into the fuller ones. The thin regions thinned further, emptying toward the great cosmic voids we have already crossed. The dense regions collapsed inward, knotting and fragmenting, until somewhere inside the largest of them, the first material grew hot and compressed enough to ignite. And the very first stars caught fire, ending the long cosmic darkness. Those stars gathered into the first galaxies. The galaxies gathered into clusters. The clusters strung themselves along vast filaments, tracing out the cosmic web that spans all of existence. And every node of that immense structure sits exactly where the early universe happened to be a fraction denser than average. Every galaxy, every star, every planet, and ultimately every living world owes its existence to those primordial fluctuations. Nothing, quite literally, created everything. It is a breathtaking claim, and it would be nothing more than a beautiful story, except that the universe left us the evidence, printed across the entire sky. When the cosmos was young, and still searingly hot, it was filled with a dense fog of charged particles, and light could not travel freely through it. Then, as space expanded and cooled, a threshold was crossed. The fog cleared, atoms formed, and the light that had been trapped was suddenly set free to stream across the universe. That ancient light is still arriving. It has been traveling for over 13 billion years, stretched by the expansion of space into a faint glow of microwaves, and it falls on us from every direction at once. We call it the cosmic microwave background, the oldest light in existence, a photograph of the universe as it was in its infancy. And when we examine that light with exquisite precision, we find it is not perfectly even. It is dappled, patches very slightly warmer and very slightly cooler than the average, temperature differences of just a few parts in 100,000. Those warm and cool patches are the seeds themselves. They are the stretched-out quantum fluctuations, caught in the act, frozen into the light of the early cosmos for us to read billions of years later. The warmer spots mark where matter was beginning to pool, the very regions that would grow into galaxies and clusters. We are looking directly at the blueprint, at the imprint of the trembling vacuum written in light older than any star. And here is what seals it. When physicists take the precise pattern of those tiny temperature ripples and use it to predict how galaxies should be spread across the sky today, how they should cluster, how they should string together, how much structure there should be, the prediction matches what we actually observe with staggering accuracy. The faint quantum noise of the universe's first instant and the grand architecture of galaxies we chart with telescopes tonight are bound together by a single unbroken thread. It is one of the most remarkable confirmations in the history of science, the link between the smallest scale imaginable and the largest, proven by the light of creation itself. So the vacuum did not merely fill the universe, it built it. But this raises a question that turns the entire story on its head. We have been treating these fields as the architects of the past, the unseen hand that shaped the cosmos long ago and then stepped back. Yet the fields did not vanish when their work was done. They are still here, still everywhere, still trembling in every corner of the universe at this very moment. So if invisible fields built the cosmos, are they still ruling it? And could the hidden energy of empty space be deciding right now the ultimate fate of everything they made? We have watched the fields build the universe. Now watch them run it. Everything that has ever happened, a star igniting, an atom forming, a particle decaying, a galaxy flying apart from its neighbors, is, at the deepest level, the same kind of event. It is fields acting on fields. The cosmos is not governed by thousands of separate rules. It is governed by a mere handful of invisible influences reaching through all of space, deciding how every ripple in every field is allowed to touch every other. We call them the fundamental forces, and almost everything you will ever witness is one of them at work. We have already crossed paths with some of them. The electromagnetic field that carries every photon also binds electrons to nuclei, holds atoms to one another, and gives ordinary matter its shape and solidity. It is the force that builds chemistry, and therefore worlds, and therefore you. Deeper down, the strong force lashes quarks together inside every proton and neutron with a grip nothing can break, holding the hearts of atoms intact against all odds. These are the architects of structure, the reason matter can clump into anything at all. But there is a third force, far quieter than the others, and almost nothing in the cosmos would exist without it. It is called the weak nuclear force, and unlike the others, its job is not to hold things together. Its job is to transform them. The weak force lets one kind of particle become another. It can turn one flavor of quark into a different one, change a proton into a neutron, and in doing so, rewrite the identity of matter itself. This sounds like an obscure technicality. It is the reason the sky is full of light. Deep in the core of every star, including our Sun, the weak force is the gatekeeper of fusion. To release energy, a star must fuse hydrogen into heavier elements. But the very first step of that process requires one particle to transform into another, and only the weak force can perform it. Without it, that first step never happens. The fusion chain never starts. Every star in the universe goes dark, or never ignites at all. The warmth on your face from sunlight, the glow of every point in the night sky, the energy that has powered life for billions of years, all of it waits on a transformation that only the weak force can allow. And when a massive star reaches the end and its core collapses, it is again the weak force at the center of the catastrophe, flooding the dying star with a torrent of neutrinos, those ghostly ripples we met long ago. In numbers so vast, they help blow the outer layers apart in the explosion that scatters newly forged elements across space. The remnants we have marveled at, the dense collapsed cores, the violently magnetized ones, the regions where space folds shut, are all delivered into existence with the weak force presiding over their birth. The forge that made the iron in your blood and the calcium in your bones ran on a force you have never felt and cannot see. So three invisible influences light the stars, build the atoms, and hold matter together. But this raises a question more fundamental than any of them. Why is there any matter to hold together at all? Here, the fields hide one of their deepest secrets. In the searing heat of the early universe, matter was being created constantly out of raw energy, but it never came alone. For every particle of matter that flickered into being, an opposite particle of antimatter was born alongside it, its perfect mirror image. And when a particle of matter meets its antimatter twin, the two annihilate completely, vanishing in a flash of pure energy. Nothing left behind. This should have been the end of the story. Equal amounts of matter and antimatter born together, meeting again as the universe cooled, erasing one another particle for particle until nothing remained but a universe filled with light and not a single speck of solid matter. No stars, no galaxies, no worlds. No one to notice the emptiness. And yet, here we are. Somehow, in the Great Annihilation, the books did not perfectly balance. For reasons we still do not fully understand, the fields favored matter over antimatter by the faintest possible margin, something like one extra particle of matter for every billion matched pairs. The billion pairs annihilated, flooding the cosmos with radiation. And that lonely 1 in a billion survivor, multiplied across all of space, is everything. Every atom in every star, every world, every living thing is built from the tiny residue that escaped the Great Annihilation. We are the rounding error of creation, the sliver of matter that, for reasons still unknown, the universe declined to destroy. Why the imbalance existed remains one of the great open questions in physics. It is another honest edge of the map, a place where we know that the fields tip the scales, but not yet exactly why. So the fields built the cosmos, lit its stars, and spared the matter we are made of. You might think that completes their reign. It does not. Because there is one more thing the fields govern, something larger than every star and galaxy combined. The fate of the universe itself. For most of a century, we assumed cosmic expansion was slowing down. The universe was flung outward by its violent birth, and gravity, the great attractor pulling all matter together, should be gradually applying the brakes, dragging everything back toward a future where expansion stalls or even reverses. In the late 1990s, astronomers set out to measure exactly how much it was slowing. They studied the light of distant exploding stars, beacons whose true brightness they understood, scattered across billions of light years. By comparing how bright those explosions should be with how bright they actually appeared, they could chart how the universe had expanded over cosmic history. The expansion was not slowing, it was speeding up. Something is pushing the universe apart, overpowering the combined gravity of every galaxy, every dark remnant, all the matter that exists, and forcing space to expand faster and faster as time goes on. We do not know what it is. So we gave it a name that admits our ignorance: dark energy. And it is not a minor effect at the fringes of cosmology. It is the dominant content of the universe. Nearly 70% of everything that exists is this unseen force, prying the cosmos apart. And the prime suspect, the leading candidate for what dark energy actually is the energy of empty space itself. We have already learned that the vacuum is never truly still, that the fields carry an irremovable energy even at their quietest. If empty space holds energy simply by existing, then as the universe grows and makes more empty space, it makes more of that energy. A relentless outward pressure built into the fabric of the void, pushing harder the larger the cosmos becomes. The same restless vacuum that seeded the galaxies may now be tearing them apart. It is a breathtaking idea, and it leads directly into the single most embarrassing failure in the history of physics. Because we can calculate how much energy the trembling vacuum should contain. We can take the quantum theory of fields, the most precisely tested framework science has ever produced, the theory that predicted the ancient light across the sky and matches experiment to more decimal places than any other in human history, and ask it, how much energy is woven into empty space? The theory gives an answer. And then we measure how much dark energy is actually out there, doing the work of pushing the universe apart. The two numbers do not match. They do not miss by a little. They miss by a factor so enormous it borders on the absurd. By some accountings, the prediction overshoots reality by up to 120 orders of magnitude. A 1 followed by 120 zeros. It is, by a wide margin, the worst quantitative prediction ever made by a successful scientific theory. The framework that built our entire understanding of reality, pointed at the energy of the vacuum, fails more spectacularly than any theory has ever failed at anything. This is not a small, loose thread. It is a tear at the very center of physics. It means that the foundation we have been standing on this whole journey, the quantum fields, the restless vacuum, the ocean beneath everything, conceals a mystery we cannot yet solve. We can measure the energy of empty space. We can watch it shape the destiny of the cosmos. And we have almost no idea why it is the size it is. But the most disturbing question is not how much energy the vacuum holds. It is whether the vacuum is holding still at all. We have been assuming this entire time that the lowest state of the fields, the floor of reality we found at the bottom of everything, is truly the bottom. Final, stable, the end of the descent. What if it isn't? What if the emptiness we are all built upon is not resting at the bottom, but merely paused, partway down, on a ledge it could one day fall off? Picture a ball resting in a valley. It sits at the bottom, perfectly still. Nudge it, and it rolls back down. It has found the lowest place it can reach, and there it will stay forever. This is what stable means. A thing that has settled as far down as it can go, with nothing below it to fall toward. For this entire journey, we have assumed the vacuum is exactly that ball. We descended through atoms, through fields, through the trembling floor of empty space, and we treated that floor as the true bottom, the lowest possible state, final and secure. But there is a second kind of valley. Imagine the ball is not at the very bottom of the landscape at all. Imagine it rests in a higher valley, a dip partway up the slope with a ridge holding it in place. From inside that dip, everything looks stable. The ball sits quietly. Nudge it and it rolls back. It seems to have found its resting place. It hasn't. Because on the other side of that ridge, the ground drops away to a far deeper valley below. The ball is not at the bottom of everything. It is only at the bottom of where it happens to be, held up by a ridge it cannot see over, unaware that a lower, more final resting place exists beneath it. A vacuum like this has a name. We call it a false vacuum. And the terrifying possibility at the heart of this chapter is that the emptiness underlying our entire universe, the vacuum we are all built upon, might be exactly this. Not the true bottom, just a ledge, a false floor with a deeper one waiting below. If that is true, then the stability of everything is an illusion. And the universe is one accident away from finding out. To understand why this is more than a nightmare scenario, why serious physicists lose sleep over it, we have to return to the strangest character in our entire story. The Higgs field. The one field that never switches off, that holds a value everywhere across all of space. We met it as the origin of mass, but that constant value it holds, the level at which it sits, is precisely the thing that determines which valley our vacuum is resting in. The Higgs is the ball. And the great question is whether it has settled at the true bottom of its landscape, or merely paused on a ledge partway down. When physicists measured the mass of the Higgs particle and combined it with the mass of the heaviest known particle, they could finally calculate the shape of that landscape and work out where our vacuum sits within it. The answer was not reassuring. The numbers place our universe in a strange and precarious spot, not clearly stable, not clearly doomed, but hovering right at the knife's edge between the two, in a condition physicists call metastable. It means our vacuum may well be a false one. It means the ridge holding us up may be real, with a deeper valley waiting on the other side. The measurements aren't precise enough to say for certain, but the most likely reading of the data is that the ground beneath all of reality is not guaranteed to be solid. Now, if a ball is trapped behind a ridge, what could possibly get it over to the other side? In our everyday world, nothing. The ball stays put forever. But we are not in the everyday world. We are in the quantum world, where the deepest rules of the vacuum still apply. And the quantum world has a way of doing the impossible. We have already seen the vacuum do extraordinary things: pull particles from nowhere, press on metal plates, bleed energy out of black holes. All of it traces to a single quantum truth. At the smallest scales, nothing is ever perfectly fixed. Everything flickers. Everything has a chance, however small, of doing what classical physics forbids. And one of those forbidden things is the strangest of all. A quantum object trapped behind a barrier does not always stay trapped. There is a tiny probability that it will simply appear on the other side, passing straight through a wall it never had the energy to climb, as though the barrier briefly ceased to exist. It does not go over, it does not break through. It is on one side, and then, by the raw statistics of the quantum world, it is on the other. We call this quantum tunneling, and it is not speculation. It is the everyday mechanism that lets stars shine and certain atoms decay. Now apply that to the vacuum itself. If our universe truly sits in a false vacuum behind a ridge, then quantum tunneling means it does not have to stay there. Somewhere, someday, in some unremarkable patch of empty space, the Higgs field could tunnel through the ridge and slip into the deeper valley below. It only has to happen once, in one tiny region. The first and only indication that the bubble has reached you is that you and everything around you ceases to exist, rewritten into a state of matter in which you were never possible. You would not see it coming. You could not. By the time any signal could reach you, the end has already arrived with it. This is vacuum decay. And the most unsettling thing about it is how quiet it is. The universe would not end in fire or collapse or a slow, cold fade. It would end with a silent bubble, born from a single quantum accident in some forgotten corner of space, expanding outward in perfect silence, erasing galaxies one by one as cleanly as switching off a light. So, should you be afraid? Here is the reassurance, and it is real. The probability of this happening in any human timescale is staggeringly, almost incomprehensibly small. If our vacuum is metastable, the typical time it would take to tunnel is likely far longer than the current age of the universe, longer, perhaps, than numbers that mean anything to the human mind. The cosmos has already survived nearly 14 billion years without it. Statistically, you are infinitely safer from vacuum decay than from any ordinary thing you have ever feared. So why do physicists take it seriously at all? Because it is not ruled out. Because the equations, as best we can read them, genuinely permit it. Because the same measurements that gave us the Higgs, that triumph of modern science, also whispered that the floor beneath us might not be final. This is not fringe doom-mongering. And when it does, that region of space discovers for the first time in the history of the universe what the true vacuum actually is. What follows is the end of everything. The instant a single patch of space drops into the true vacuum, it becomes a place where the laws of physics are subtly, catastrophically different. The strengths of the forces change. The masses of particles change. Atoms, as we know them, the delicate arrangements that make stars, planets, and living things possible, can no longer hold together. In that patch, the structure of matter itself simply ceases to be allowed. And the patch does not stay a patch. The true vacuum is lower than ours, a deeper valley, and like water bursting through a dam, the lower state floods outward into the higher one. A bubble of true vacuum forms and begins to expand, its walls sweeping through space, converting everything it touches into the new reality. Inside the bubble, the universe we know cannot exist. Outside it, for now, everything carries on as normal. But the wall is closing in, and it is moving at nearly the speed of light. Sit with what that means. The boundary of annihilation races outward at very nearly the fastest speed anything in the universe can travel, and almost nothing travels faster, including any warning of its approach. The light from an oncoming bubble wall arrives at essentially the same moment the wall itself does. There is no flash on the horizon, no tremor, no sign in the sky. It is a sober conclusion that falls out of our most successful theories when we follow them honestly all the way to their edge. The very framework that explained the light of creation and built our understanding of reality also tells us that reality may not be permanent. And it need not even be the Higgs that fails. Any field settled in a false valley, anywhere in the hidden landscape of physics, could, in principle, do the same. The vacuum we have spent this whole journey learning to respect, the restless, creative ocean beneath all things, may also carry, folded into its silence, the seed of an ending. But notice what this whole terrifying possibility quietly assumes. It assumes there is a stage for the bubble to expand across. It assumes space and time are simply there, a fixed arena in which fields tremble and bubbles grow and galaxies are erased. We have spent 6 chapters treating space as the container and the fields as its restless contents. What if that too is an illusion? What if space and time are not the stage at all, but just another layer of the performance? Not the floor beneath the fields, but something woven somehow out of the fields themselves. To answer that, we have to ask the final and deepest question of all. Not what fills space, but what space is. We have spent this entire descent asking what fills space. Now we ask the question we have been quietly avoiding all along. What is space? For 6 chapters, we have treated it as the stage, a fixed, smooth, featureless arena in which the fields tremble and the drama of the cosmos plays out. Space was the container. The fields were the contents. It seemed beyond question. But the deeper physics has looked, the more that assumption has begun to dissolve. And the suspicion now creeping into our most fundamental theories is staggering. Space may not be fundamental at all. It may be made of something. To see why, we have to confront the one place our understanding has never been able to reach, the single unhealed wound at the center of physics. We have 2 magnificent theories of reality. One describes the very large, gravity and the way mass bends the shape of space and time, governing planets, stars, and galaxies. The other describes the very small, the quantum world of fields and particles, the trembling vacuum we have explored this whole journey. Each is among the most successful ideas humans have ever had. Each has been tested to extraordinary precision, and they are utterly incompatible. Push them together, ask them to describe the same place at the same time, and they don't merely disagree, they break. The equations spit out nonsense, infinities, answers that cannot be true. For most of the universe, this never matters. Gravity rules the large, the quantum rules the small. Their territories rarely overlap. But there are places where they are forced into the same room, where something enormously massive is also crushed, unimaginably small. The heart of a black hole. The first instant of the cosmos. There, both theories must apply at once, and there, both collapse. At those points, physics as we know it simply stops having anything to say. To describe those places, we would need a single theory that contains both. A theory of quantum gravity. It is the great unfinished business of science, the missing capstone we have been chasing for a century. And every serious attempt to build it keeps arriving at the same revolutionary suspicion, that space and time are not the foundation, that they emerge, woven out of something more basic underneath. To find where the stitching shows, you have to go small, smaller than an atom, smaller than a quark, down and down past every scale we have ever crossed, until you reach a size so impossibly tiny it has its own name, the Planck scale. It is the smallest length that has any meaning in physics, so small that the number of Planck lengths across a single proton dwarfs the number of protons it would take to fill the visible universe. It is the bottom of the ruler, the place where the very idea of distance begins to give out. And our best reasoning suggests that down there, at that unreachable scale, the smooth, calm space we take for granted is not smooth at all. Remember the lesson that has run through this entire story. Nothing in the quantum world holds still. The fields tremble, the vacuum shivers, and space itself, examined closely enough, should be no exception. At the Planck scale, the gentle fabric of space and time is thought to come apart into a roiling, violent chaos, a churning, blistering froth where distance and duration lose their meaning, where the geometry of reality boils and reforms moment to moment. Physicists call it the quantum foam. The placid emptiness we have been crossing all along, magnified to its ultimate limit, may be the most turbulent place in all of existence. A storm so fine-grained that from our vast height it averages out into the serene, silent space we think we know. The stage, looked at closely enough, is shaking. But if space is foam at the bottom, if it has a structure, a graininess, a texture, then it is not the smooth, infinitely divisible backdrop we imagined. It is built from something. And the deepest theories, now competing to finish physics, each offer a different answer to what that something is. One says reality is made of vibrations. In string theory, the fundamental ingredients of nature are not point-like particles at all, but unimaginably tiny strands of energy vibrating. Every particle we have met, every ripple in every field would be one of these strings, humming at a particular pitch. Change the vibration, and an electron becomes a quark becomes a photon. All of matter, all of force, reduced to a single kind of object playing different notes, the universe as a vast, silent symphony. In its boldest forms, the theory suggests that space itself and even gravity arise from the behavior of these strings, that the dimensions we move through are not the starting point of reality, but a consequence of something deeper. Another says reality is made of space itself, broken into pieces. Loop quantum gravity takes the opposite path. Instead of building space out of strings inside it, it proposes that space is the fundamental thing, but that it is not smooth. It is woven, like fabric, from discrete threads, tiny, indivisible chunks of volume linked into a network. In this picture, there is a smallest possible piece of space, below which smaller has no meaning. The seamless continuum we move through would be an illusion of scale, the way a photograph looks continuous until you bring it close and find it is made of grains. Space, in this view, is not the stage. It is the most fundamental quantum object of all. The two theories disagree about almost everything, but notice what they share. What nearly every serious attempt to finish physics now shares. In each of them, the smooth space and flowing time we have treated as the bedrock of reality are not the bedrock. They are emergent, built, assembled from something underneath that is not itself spatial at all. And the strangest clue of all about what that something might be does not come from strings or loops, but from the unlikeliest place imaginable, from black holes. We have circled the black hole many times on this journey, the end point of collapse, the slow bleed of Hawking radiation, the knife edge where the vacuum gives up its ghosts. But hidden in the physics of black holes lies perhaps the most profound clue we have ever found about the nature of reality. When physicists worked out how much information a black hole can contain, how much can be hidden inside it, they expected the answer to depend on its volume, on how much room there was inside. It did not. The answer depended only on its surface area, on the size of its boundary, not the space it encloses. Everything the black hole contains, the entire three-dimensional interior, can be completely described by information written on its two-dimensional surface. This sounds like a curiosity. It may be the deepest hint we possess. It suggests that a volume of space and everything in it can be fully captured by information on a surface surrounding it. That the inside is, in a sense, a projection of the boundary. Carried to its conclusion, it raises a possibility that borders on the unbelievable. That our entire three-dimensional universe, with all its depth and distance, might be encoded on a distant two-dimensional surface. That the space we move through is a kind of projection, the way a flat hologram can conjure the illusion of a solid object floating in the air. We call this the holographic principle, and it points toward a single vertiginous idea, the one that may lie at the very bottom of everything. That the ultimate stuff of reality is not matter, and not even fields, and not space or time. It is information. That underneath the strings and the loops and the foam, beneath the fields and the trembling vacuum, the most basic currency of existence may be something closer to pure relationship, pure distinction. And that space, time, matter, and force are all the way that information arranges itself into the world we experience. We do not know if this is true. Let us be honest here at the end about how much remains dark. We do not have the final theory. We have not unified the large and the small. We have not seen the quantum foam, or a string, or proven the universe is a hologram. These are the frontiers, the places where the map runs out and the equations point into territory no experiment has yet reached. The deepest question of all, whether reality is fundamentally made of fields, or geometry, or information, or something we have not yet imagined, remains open. It is the question the next century of physics exists to answer. But look how far the descent has taken us. We began by holding up a hand to the dark and seeing nothing between the stars. We have ended by suspecting that the stars, the dark, the space between them, and the hand itself may all be expressions of a single hidden order. That the emptiness we once dismissed was never empty, was never even truly space, but the visible surface of a reality far stranger and far deeper than our senses were ever built to perceive. Space looked empty for one reason only. We were never equipped to see what it is made of. Beneath every star, every world, every atom of your body lies the restless quantum ocean we have crossed together. The trembling fields that conjured the galaxies, that light the suns, that may one day rewrite reality in a single, silent bubble, and that we are only beginning to suspect are not the bottom of anything at all. The greatest discovery is not what fills the universe. It is that the emptiness was the universe, and that the deepest layer of all still waits, in the dark, for someone with the courage to keep descending. We looked up expecting to find nothing. We found instead that nothing was the most extraordinary thing there is.